Unit 2, Lesson A, Polynomial Review. We need to remember how to multiply polynomials and how to factor them before we can even start this unit. So, let's take a look at what we used to do. So, multiplying polynomials, there's a couple different strategies. So, if we multiply two binomials means there's two terms in each set of brackets. Okay? So, how do we do that? We can use FOIL or the area diagram. What if there's only one element or one, what are those called, term in front of the brackets? How would you multiply the first example? What do you do there?
The both.
Yes, it's the distributive property where you times it into both. So we could use the arrows to show us how to do that, or we could do a 1 by 2 box, okay? I'm going to do a 1 by 2 box just because I like the box method, okay? So, on the left I have 2x. On the top, I would have x squared and subtract 3. Okay? Now, 2x is going to multiply to an x squared. Remember, digits in front multiply by digits in front. And with variables, you're going to add the variables when you multiply, if it's the same letter. So if you take a look right here, I've got x's. I have a 2 on the x here and a hidden 1 there. So I'm going to add them when I multiply them. And the big 2 is going to multiply by that hidden 1 in front of x squared. So I'm going to have 2x cubed is what that's going to give me. Then I take a look at and multiply the negative 3. It doesn't have an x, so you can only multiply the digit 2. So that's going to give me a negative 6. The x has to come along attached for the ride. Now why does it get attached? Because the x is already attached to this one. Okay, so it has to stay attached. Okay, on the bottom one, you are going to do an area diagram or do FOIL. Now, on the first example, pardon me, can we just leave it in the boxes like that? No, we need to take our answer out and write our answer properly. So that's going to give us 2x cubed minus 6x. Okay, that would be our final answer for that one. Okay, give example 2 a try, push pause now and play when you're ready. Okay, so you have a couple minutes to look at this one. You should have been able to multiply. When you're multiplying again, you're going to add the exponents on the variables that are like variables. So this one will give you 6x squared, because the 6 is going to multiply by that hidden number 1. Okay? Now we're going to multiply the 6 times the 5, so it's 30, and the x goes for the ride. I have the 1 times by the negative 1 to give me negative 1, and the x comes down for the ride as well. Now, do you have to show that it's a negative 1 sitting in front? No, you can actually show that it's just a negative x. If you write it as negative x, that's okay. It just means it's got a hidden negative 1 there, okay? All right. 5 times a negative 1 gives me a negative 5. Now I look in my boxes. Do any of those have the same letter with the same exponent on it? Yes, they do. Those ones are the same, which means they're like terms. Okay? They have the same variable and same exponent on that variable. It's a hidden 1. So you're going to add the digits in front. Okay? So you get 29. So our final answer we're going to write is going to be 6x squared plus 29x minus 5. What kind of an answer did I create? I started with 2 binomials. What did I create? A trinomial. Good. All right, let's go to the next one. What if I've got a number or an expression that has more than 2 terms? How do I multiply this example? Right, you just put one more row or one more column on your box. Okay? So, there's 2 ways to do this question. If you like to do it by distributive property, you would just take the one with the least amount of terms and multiply it into the bracket. Okay? As long as you do it to both. Or, we can open up a 2 by 3 box. Okay? And I like the box method, so I'm going to open up a 2 by 3 box. Now, the box method tends to be a better method to use. How come? Because that means you won't forget to multiply something. Okay? If you just do this rainbow distributive property method, sometimes you end up forgetting something. Okay? But if you have the box method, you know you've got to multiply to fill something in the box. Okay? So give that one a try. Okay, you've got a few minutes to look at this. Let's see what we get. So take 3 times 2, we're going to get a 6. Add the exponents on your x, you get x cubed because there's a hidden 1 on that x. Take your 10 times a 2 to give you 20, and we add the x's to get x squared because this one also has a hidden 1. Over on the right, negative 9 times 2 gives us a negative 18. The x comes for the ride. On the bottom, 3x squared. Everything times 1 will just give its exact self. So basically your top row can just be written in the bottom. So 3x squared, 10x minus 9. All right. Now we're going to check and see if we have any like terms. Like terms are ones, remember again, they have the same variable and same exponent. Now if you set them up in descending order means highest exponent to lowest exponent to no variables. If you set them up into that order, they will always be diagonal. So check diagonally and you will find your like terms. So my x squared, whoa, tricky, okay. Here we go, let's go diagonal. Diagonal is my x squared, I can add the digits in front. Over here, same thing, diagonally I can add the digits in front. Okay? So our final answer is going to give us 6x cubed, nothing adds to the first one. We add the next two, we get plus 23x to x squared. We have to put a plus sign in between them because they're positive. You can't just stick them side by side. If you do, that means they're multiplying. They're not multiplying. Then you've got your negative 18 and a positive 10 to give you a negative 8 x's, and your negative 9 goes to the end because nothing adds to it. Okay? And again, these are written in descending order, meaning highest exponent to lowest exponent to no exponents. Now your exponents are called degrees. Do you remember that from 10C? So they're called the degree. This would be considered a degree 3 polynomial. 3 because it goes by the largest exponent. Okay, so the largest exponent names your polynomial. So this one's a degree 3 polynomial. Now remember, the constants are terms that have no variable. They are considered to have a degree 0. How come? Because they have no letter. They have no variable. That's why it's a 0. So here I've got a degree 3. I have a degree 2, degree 1, and degree 0. And they're written in order of descending degree. Okay, big to small. All right, but who gets to name it? The largest names it. So it's a degree 3 polynomial. Okay, let's take a look at the next few examples. We're going to be talking about removing common factors. This is also known as GCF, greatest common factor. So when we factor out, factoring means dividing, okay? When you're factoring, you're dividing by something. So we're going to divide out our common factor, and we place it outside the bracket. So the GCF goes on the outside. Then the answer to dividing goes on the inside of brackets. That's how you create your factor. So on the first set here, what would be the common factor in them?
5.
Okay, 5 and the W. Now how do we come up with those? The first thing you do is you look at the digits. The digits themselves, you need to be able to divide them without creating a decimal. They have to divide evenly. So both of them divide by 5. Okay, so I'm going to divide them both by a 5. Now what do we know about the W's, the variables? How do you know how many you can take out? The least amount. Good, it's the least amount. So the least amount is a W1 because the guy on the right, the 35W, has a hidden 1 on the exponent. So I'm going to divide by 5W. This is now called my GCF. That's my greatest common factor that I'm dividing out. Okay? So my answer, sorry?
Do you have to say the GCF question, like to get the answer right?
Well, sort of. You don't have to write the word GCF. What you're actually going to do is you're going to place it like this. The GCF goes in front of the brackets. Okay, that's what you divided out. So we put our 5W on the outside of brackets. Now we're going to divide each term by that 5W. Okay? So you divide digits by digits and subtract exponents on variables. So 5 divided by 5 gives me my hidden 1. W squared subtract W1 gives me 1W left. So W exponent 1 left. Do you have to show those hiding ones? No, you don't. Okay, then I take my 35 and divide by 5. I'm going to get a positive 7, so you must attach it with a plus sign. And then your W's are going to disappear, because 1 subtract 1 gives you 0. You're not going to write W0, okay, because anything exponent 0 gives us a positive 1. So we do not have to write W0. It just completely disappears. And then the 1 would times by the answer itself. Okay, 1 times anything, it's just the same answer. So inside the bracket, we would have W plus 7. Okay, This is considered my final answer. Okay? You need to have that GCF attached out front of the bracket. You can't just have the W plus 7. You need to know what it was divided by. A good way to check your answer is to put it into an area box. So let's take a look and put this guy into an area box. Will we get the same answer? Yes, you're going to get the exact same answer. You should. If you don't, you know you've done something wrong. Then you go back to the start. So if I put my answer, 5W and W plus 5, into an area box, it'll look like this. I took out a 5W, and W plus 7 goes over here. Now you multiply it out. 5W squared, 35W. Is that what I started with? Yes, it is. So you did it right. Okay? So it's a back and forth opposite function. Okay? You can always check your work by putting it back into an area diagram. All right, let's take a look at B. Okay, so they all divide by 5, and we can take out how many W's? 2, good. So a good strategy, if you've got more than one thing on top, is to write your greatest common factor underneath each of them. So I'm going to divide by 5W squared, 5W squared, 5W squared. Sometimes it's easier if you do it for each, rather than just dividing it once on the bottom. So I put my 5W squared on the outside of brackets, and my answer goes on the inside. Now I'm going to literally divide the digits. So 15 dividing by 5, I'm going to get a 3. Now you subtract your variables. Subtract the exponents because they're the same variable. So 4 subtract 2 gives me 2 left over. Good. Now I've got a 25 dividing by a 5. What am I going to get there? 25 divided by 5. Is it? Yeah, it's a negative sign. Thank you. I just have to check and make sure. So it's a negative 25 dividing by 5. What do I get? A negative 5. How many W's are left over? Just 1. Good. On the back one, 5 divides by 5 how many times? 1 time. So you have to put the plus 1. And then what happens to your W squareds? They cancel out and disappear. So they disappear completely. But can you actually leave that without the 1 on the end? Okay, could I have that answer look the same as this? 5W squared times 3W squared minus 5W. Are both of those the same? No, they're not. Okay, you have to put that 1 there. If you don't put the 1, it looks like you only have 2 terms that you multiplied or divided to begin with. You actually had 3 to start with. So you need to put that 1 there because it's a placeholder. Okay, so that 1 exists. You have to have that 1 there. Okay, let's take a look at the next 2 examples. Give them a try on your own, and then push pause now and play when you're ready. Okay, you might notice that sometimes you don't always know which numbers they divide by. Sometimes you have no clue what they divide by. Well, there's a button in our calculator that can create the greatest common factor for us. It can tell us what it is. So everybody follow along. Please find your calculator. You're going to hit the math button. Okay. You're going to go across the top where it says NUM. It stands for number. So hit your right arrow to the top, and it brings up a new menu. Now what you're going to do is scroll down to the bottom to number 9. Okay, so scroll down to number 9 and hit enter. It says GCD. That's greatest common denominator is what it actually is. So what we're going to do, what is your greatest common factor? Now you can't put 3 numbers in. It'll only take 2 at a time. So we can check the first 2. So what you're going to do is you're going to go 9 and 20, negative 27. So the first thing you're going to actually just take the digits, forget the names, fine. But just take the digits. But you can only put 2 in. They have to be separated by a comma. So you're going to go 9, comma, 27, enter. Okay? And that'll give you the number. Okay? That'll give you the number to divide by. Okay? Then you have to check the next 2. So these guys all divide by 9. Let's check the next 2 and see if they do. So I got to check 27 and 12 now. So they both divide by 9. So I'm lazy. I don't want to retype that in and go to my menus. So a way to get your calculator to retype something and back up a step is what it's doing is you hit second enter. Okay? So go second enter and it's going to retype your last step. Now your cursor is on the same level. So you're able to move your left arrow on top of the numbers and retype numbers. Well, so just retype the numbers on top. So we're going to hit 27, comma, 12. Let's see what the greatest common factor there is. Well, there it says it's 3. So that means 27 and 12 can only divide by 3. Well, does our first number 9 divide by 3? Yes. So then we found our greatest common factor there. Okay? Let's try the one on the right-hand side, 36, 60, and 84. So let's take the first two. So we want to retype it again. So I'm going to hit second enter, and it comes back up for me. Hit your left arrow to type on top of the numbers. And now you're going to type in 36, 60. Hit enter. What do they have in common? They can divide by 12. Now let's take the next two digits, 60 and 84. So I hit second enter again to retype it. And I type in 60, 84. What do they divide by? They also divide by 12. Well, I've checked the first two and the last two. Now I need to check the first and last. You have to check all three combinations. So I'm going to hit second enter again. And I'm going to type in 36 and 84. So 36, 84, enter. And what's that going to give me? Whoopsie. What did it tell me? Oh, I put a plus sign. Okay, let's go back to that and put a comma where it belongs instead of a plus sign. Okay, there we go. Now hit enter. It also divides by 12. So all three combinations gave us a 12. So we're going to divide by 12 as our greatest common factor on this one on the right. Okay, so we found our greatest common factors on the left. We're going to divide by 3. And then on the right, we're going to divide by 12. Now we need to know what the variables we're going to divide out. So over here, we're dividing by 3. Over here, we're dividing by 12. Now, which variables come out how many of them? You always take out the least amount. And it also has to be in each term. So on the left-hand side, all 3 of x is perfect. What is the smallest number? 2. Good. So we're going to divide by 3x squared on the first one. All 3 of them divide by 3x squared. So 3x squared is going to go on the outside of our bracket. The answer to dividing them is going to go on the inside. Each of those are called factors. The one on the outside is called the greatest common factor, and the other one on the inside is just called a factor. Okay? Because a factor times a factor gives you an answer, okay? Factor is multiplying, an answer from multiplying. So, if we take a look at B, we're going to divide by 12. How many x's can I take out? 1. This guy only has a hidden 1 there, so I can only take x1 out of each of them. How many y's can I take out of each of them? 1. Good, this guy has a 1. Okay. So on this one, we're going to have a 12xy on the outside of brackets. And then we put the answer on the inside. Okay, let's divide them. 3 dividing by 3 gives me a 3. I subtract my x's and get x squared. 27 divided by 3 is a negative 27. I'm going to get a negative 9. How many x's left? 1 of them. Good. Do you have to show that hiding 1? No, but you have to know he's there. Now you take the 12 and divide by 3, you get 4, it's a positive 4, but your x squareds are going to disappear, they cancel completely. Okay, so on the bottom, on the right-hand side, you only have a 4. And again, on the inside of your brackets, you're going to notice the exponents go from largest to smallest to no variable. So I've got squared, x to the 1, and then no x's. That's how it should be written, biggest to smallest. It's called descending order. Okay. Take a look at the next one. Again, divide the digits. 36 dividing by 12 will give me a 3. Subtract the x's and y's. 2 subtracting 1 gives me 1x left over. 4 subtracting 1 gives me 3 y's left over. 60 dividing by 12 gives me a 5. Good, it's positive 5. x3 subtracting x1 gives me an x squared. y1 and y1, what happens to my y's here? They disappear and cancel. Okay, let's take a look at the next one. I need more room. I'm going to move these guys over. And we're going to group those guys so they can go smaller. Let's make them smaller. Okay. Now, on the right-hand side, I've got 84, negative 84 divided by 12. How much does that give me? Negative 7. Okay, just negative dividing by a positive. Your x1 and x1, your x's will disappear and cancel completely. Now you've got y cubed subtracting y1 to give you y squared. This would be your final answer, okay? You cannot go any further unless they tell you what to substitute for x and y, okay? That'll be as low as we can go. Okay, now some of you divided by a different number. Look what happens if you divide by a smaller factor and not the greatest common factor. Okay, so let's say, for example, you divided by 4xy. If I divided by 4xy to all of them, I'm going to have a digit out front that is going to be able to divide out again. So take a look. If I divide that out, I get a 4xy outside. On the inside, I'm going to get 9xy cubed plus 15x squared minus, what's that going to be, 21 and y squared. Okay, if you take a look at all those, every single digit, the coefficients, every single one of those can still divide by 3. So you'd have to divide it all out again. So this time now we're going to divide by 3. And whatever number you divide out, again, just like our radicals, if we pulled another number out, it has to multiply to the digit you started with out front. So that means the 3 we're going to divide by is going to multiply by this 4. And what's it going to create? It's going to create the 12 we have here. Okay? And we'll get the exact same answer after. So if you started bigger, okay, if you started smaller, and you ended up with a number that could still have common factors, you still have to divide out common factors until you reduce it low enough. Okay? When you divide those ones out by 3, it'll give you the answer we have above. Okay? Now we get into my favorite kind of factoring. This is called difference of squares. Difference of squares are a lot of fun because there's only one way to do them. Okay? And that's by square rooting both ends of the polynomial. Now, difference of squares, the word difference means subtract. So that means in between the two digits, you need to have a subtract sign. Okay? So another way to think about it is that they've got to be opposite signs. One will be positive, one will be negative. Because often they mix them around when they actually write them. Okay? And they expect you to rewrite them a different way. Okay? Now, when you're doing these kinds of things, you automatically open up 2 brackets. Okay, so here are the rules first. So we're going to remove a GCF if possible. That is always our first step. You always see if both numbers can divide something out. If they do, remove it first. Then you open 2 sets of brackets. So I'm going to open 2 sets of brackets. I square root both terms. So I'm going to square root both terms, and I put my answers inside the bracket. Now, the first term that gets square rooted, his answer will be written in the first spot in both brackets. The last term, his answer will be written in the last spot in both brackets. Okay? So the square root of 4 is 2. The square root of x squared is x to the 1. Okay? Now we want square root 9. What is the root of 9? 3. So I put a 3 at the end. To finish my answer, all I've got to do now is put opposite signs in the brackets. One's a positive, one's a negative, you're done. Okay? It's seriously that easy. Okay? All right, let's put a few more examples. All right, do 9 and 64 divide by any other number that leaves both answers still as perfect squares? They both divide by 3. But when I divide them by 3, will I still have perfect square answers? No. So you only divide it out if it leaves you a perfect square answer still. So this one, we're not dividing out the 3 because when I do, I'm not going to have perfect square answers. So if I divide the 9 by 3, I get a 3, and 3 is not a perfect square. If I divide 64 by 3, I get 18, and 18 is not a perfect square. So you're not going to divide a GCF out of that one. All you're going to do is you're going to square root them because they're perfect squares. So square root, let's open 2 brackets. Okay. The root of 9 is 3. The root of x squared is x. The root of 64 is 8. The root of y squared is y. Okay? What do I do now? What's my last step? Plus and minus. Good. Positive, negative, done. Okay? You check inside your brackets. Can anything else be square rooted again? No. If nothing else can be square rooted again a second time, then you're done. That's our final answer. Okay? Let's take a look at B. If I divide out a GCF of B, do both of them still stay as perfect squares? In this one they do. Watch. If I divide out a GCF of 9, if I divide that out, both of them are still perfect squares. So that gives me 9, x squared subtract 9. Now we know that the number 1 is a perfect square. Okay, so I have a hidden positive 1 in front of x squared. He's a perfect square. Anything with an even variable, or sorry, an even exponent on the variable, they're all perfect squares if it's an even number. Okay, so 2, 4, 6, 8, 10, those are all perfect squares. Because what you do with your variables when you square root them is you're actually dividing them by 2. You divide them by the index. Okay, that's all you're doing. So, I have exponent 2, I'm dividing it by the index 2. What do I get? A 1. That's how I get x to the 1. Okay? So, this will open 2 brackets again. I square root and square root. I will get x at the front. I square root 9 and I get a 3 at the back. And now I separate them with a plus minus. Okay? And now you're done. If you left it at this step, you're not done yet. Okay? You would only get a half mark if you left it like that. Okay? You need to take it till it's fully simplified. That's fully factored. Okay? Let's take a look at the next couple. The next one has a GCF that comes out. What can I divide out of the left there?
X.
An x, good. You always want to divide them out so that you have even numbers on your variables. Some of these have odd numbers, so try and divide the odd number out. So I can take an x to the 1 out. So when I do that, it becomes w squared y squared, because the x will disappear here. And I'm going to subtract 1x here, so I'm going to get x squared z squared. Okay? Because there's a subtraction sign. Okay, so if we take a look at this one, we're looking for exponent 2, that they all have exponent 2 so I can square root them. Yes, they do, so you want to cut them in half. You have to look for a negative sign. Are the signs opposite? One positive, one negative? Yes, then you're able to do it. So I can square root, square root. I still have my x out front. I open 2 brackets.
And we're
Last step, divide out, square root both ends. You're going to get wy at the front of both, and at the back of both, you're going to get an xz between them, plus, minus. Now we're done. Okay, if we take a look at letter D here, what is the square root of 1? It is 1. Good. Now, you can square root 1 many, many times. It depends on how you do the question. So, let's take a look here. Again, you need to square root both ends and open up 2 brackets. First rule. Okay, 2 brackets, square root both. What is the root of 16?
4.
It's 4. Good. Now, what is the root of x exponent 4? X squared. Good. Because remember, all you're doing is you're taking the exponent and you're dividing it by the index. So 4 divided by 2 is 2. So you get an x squared and an x squared. Okay? What is the root of 1? 1. Good. And then again, put your plus minus. All righty. So, does anybody see any other bracket there that can even go lower? Do you know another one in that set of brackets? Am I done with this final answer? Well, we're not going to GCF it. We're going to do something else.
So do you only divide one part of it?
That's right, only one part of it. Now, which one can do the positive or the negative? The one with the negative sign, okay? The one with the plus sign has to just come down by itself. It cannot go any further. So, 4x squared plus 1 will not reduce. You cannot factor him because he's got a plus sign there. Okay, you're always looking for a difference of squares. You're looking for a subtract sign in the middle. Okay? Now, the one over here He's got a subtract sign in the middle. Can I square root the 4 and the 1? Yes, they're both square rootable. So if you can break it down lower, you have to. So this is going to open up another 2 brackets. Okay? And then you square root both ends again. So I'm going to square root my 4x squared and square root my 1. So I'm going to end up with 2x in the front, because that's the square root of 4x squared. And again on the end I get a 1, because the square root of 1 is 1, and you separate with a positive negative. Okay? Now again, you look at all of them, and you check and see, can anything else be square rooted with the ones that have a subtraction sign? Well, the only one with a subtraction sign is that one. Can it be square rooted? No. The 2x cannot be. The 1 can be. We can always square root 1, but we cannot square root the 2x. So that means we're finished now. Final answer. Okay? Does it matter the order you write it in? No. That's your final answer. Okay, you got a couple minutes? The first one you always check on every single question. You always check, is there a GCF you can divide out? On the first one, there's no GCF. So the next thing you do, you notice there's 2 terms with a subtraction sign between. That's what you're looking for. So now you're going to square root. Open 2 brackets. You get x to start. The root of 25 goes in the end, which is 5. Separate with a positive negative. Okay, final answer. Moving to the next one, the 2x squared. Here's our 2x squared. What we're going to notice is you can divide both of those by 2. You need to take a GCF out first. If you take a look at those digits, neither of those are perfect squares. But when you divide out the GCF, they become perfect squares. So I'm going to divide out 2. So when I divide out the GCF, it has to be attached to the front of the brackets that I open. So I'm only taking a GCF out. So I'm going to open 1 bracket and just divide them. Okay? So you're going to get x squared minus 49. Now you look at the new numbers in the bracket and see if either of those can be square rooted. They both have to be able to be square rooted before you break it down again. Yes, they can be square rooted. X squared can be square rooted and so can 49. So now you're going to break down 2 brackets again. But the 2 that you already divided out, that GCF, it needs to stay attached to that front bracket because it's part of your original solution. So it's got to stay attached. Oops, it's a 2, not a 3. Okay, so we've got a 2 in front. Now we square root x squared to get x in front. You square root the 49 to get a 7 at the back. And separate with a positive negative. That would be your final answer. Okay? Because neither of those in the brackets can be square rooted anymore. And neither of them have GCFs that can still come out again. We look at the third one here. We can divide 3 out first. So we're going to divide by a 3. When we divide by a 3, that's our very first step. We don't open 2 brackets because it's GCF coming out. So that means we're just dividing the 3 out of the digits. So now I'm going to get x squared minus 16y squared. So now what you're going to do is, again, check inside. Can they be square rooted? Yes, they can, because they both have an even number exponent. So now when you get to this point, just like you did with the one on the right, the 3 comes down, and now you open 2 brackets. Root of x squared, x, the root of 16, 4, the root of y squared, y, separate with a positive negative. Okay? Now that's finally completely done. Okay? Any questions? Okay, here we go. We have the next type, which is factoring trinomials with a equals 1. So your trinomial needs to be set up with the largest exponent, again, to the least exponent. So if we take a look, we've got an exponent 2, and in front of exponent 2 is what we call the a factor. Then we have a b digit, the coefficient, in front of x to the 1. And then c is known as our constant. He doesn't have a variable. Trinomials are always set up in that way. Now when we factor a trinomial, we need to find out what factors multiply to create your c term. That's what's going to end up in your 2 brackets. And there's a method we use, and it's called the diamond method. So your diamond method works this way. You take, for the top number, you take the a digit times the c digit. So my a here is a 1, My B is the 8, my C is the 15. So the first thing you're going to do is label them. Okay, I know who my ABC is now. Now I multiply A times C, I get 15. On the bottom of your diamond is your B value. Your B value here is 8. Now what we do with our diamond is we try to figure out which two digits multiply to create the top number, but they add to give you the 8. Now how do you do that? You create a factor list of the A times C. So you're going to factor 15. What are the factors of 15? 1 times 15. 3 times 5. Those are the only factors of 15. Because we have those factors, now we take a look at them and we see if we add them. Well, if I add those factors, this one gives me 16, this one gives me 8. Which one gives me the bottom number? The 3 and the 5. Good. So now what I do is I put this 3 and this 5 on what I call the wings of the diamond. They go on the left and right. So the 3 will go here, the 5 will go here. Now those digits on your wings of your diamond, if you only have a digit 1 in front of your x squared, all you do now is open two brackets, you square root x squared, he goes in the front of each bracket. So, two brackets, we square root x squared, we get x and x. Now we look at our diamond. The numbers on the wings of the diamond are the numbers on the ends of each bracket. So I have a 3 here, a 5 here. Does it matter the order they go in? No. They're both positive, so you put a positive in the middle. That is your final answer. Okay, next question. Again, you open two brackets. Let's draw our diamond. I label my A, my B, and my C. So my A number is a 1, my B number is a -1, and my C is -12. So A times C on top gives me a -12, 1 times -12. My B digit on the bottom is going to be a -1. Now I factor -12. Okay, so -12 factors into 1 times 12, 2 times 6, 3 times 4. It's a negative, so that means you have to find the big numbers are negative. How come the big numbers? So that when you add them, you're going to get a negative answer. So your big numbers become negative. Now let's add them. This one will give me a -11. This one gives me -4. And this one gives me -1. I'm looking for a -1. So I'm going to use 3 and -4. So 3 and -4 go on my wing. Oh, goodness. Okay, 3 and -4. So the 3 and the -4 now go at the ends of my brackets. So I have a 3 and a -4. I square root my x. Okay, you square root x squared and throw him in front. Am I done? What's missing? The plus sign. Good. You have to put that plus sign there. Okay? The negative sign belongs with the 3. Or sorry, with the 4. Because -4 plus 3 gives you the -1. Okay? When we take a look at these, the very first one, how do you know whether you're going to square root them, if you're going to do a GCF, or if you're going to do a diamond? You count the number of terms. This one has 3 terms. If it's got 3 terms, the first thing you check is GCF. Nothing divides out about any of them, because they can only divide by a 1. If they can only divide by a 1, that's not a GCF. They have to divide by a number bigger than 1. So, we go right to our diamond on this one. This is the A term, B, and C. So A times C here gives us 10 on top. On the bottom we have a 7. What are the factors of 10 that give me 7? 1 and 10 or 2 and 5? 2 and 5. So now I open my two brackets. I square root my x squared, I get x. And now I take my 5 and my 2 and I put them at the ends of my bracket. And I separate with plus signs because they're both positive. Okay? Now we take a look at B. B is also 3 terms, and none of them are square rootable, except for the x squared, of course. So now, again, you got to use your diamond. When we use our diamond over here, here's our A, here's our B, here's our C. A times C gives us a -10. Our B is a -3. So now we've got to find the factors of 10 that give us a negative 3. Well, again, the only factors of 10 are 1 and 10, 2 and 5. Which one's got to be negative in order to give me a negative 3? The 5 has to be negative. Because when you add them, okay, this will give you a negative 11, or sorry, a negative 9, pardon me. And the one over here is going to give you a negative 3. Okay? Now, how do we know which number gets the negative sign? The number in your B term tells you which one's going to be negative. And it's always the big number is going to match the sign of the B term. So your big number is going to be a negative because your B term's a negative. That's why the big number was negative here. Okay? If your B term was a positive, then that means your big numbers would have been positive, the small numbers would have been negative. Okay? That's how you tell. The B number tells you whether the big number is going to be positive or negative. Okay, your B term, they match the B term. Okay, so now we know those digits. So we know it's going to be a positive 2 and a negative 5. Those are the numbers we put in our diamond. So I can erase what I've got over here. I open my 2 brackets. And I have X, and I have a negative 5 and a positive 2. Final answer. Okay? I look at C. C has 2 terms. So when you've got 2 terms, there's 2 things possible. GCF or difference of squares. Which one is it? Difference of squares. The minute it's a difference of squares, you just square root both ends. Square root the x squared, square root your 16. Open 2 brackets. X starts your bracket, the root of 16 is 4, and you separate them with a plus and a minus. Okay? On letter D, same thing, 2 terms with a negative sign between them. Square root both sides, open 2 brackets. Square root of 4y squared is a 2y that goes in the front. The root of 25 is 5. And again, we separate with a positive and a negative sign. Okay, then we're done. The last couple questions here, we're going to notice there's lots of different variables and lots of different exponents on our variables. The only thing we can do if we can't square root these guys is take a look at their GCF. We have to divide out a GCF. So I'm going to divide each of those by a GCF. So a greatest common factor means I look at the digits in front, my coefficients. What do 8 and 10 both divide by? They both divide by 2. I take out the smallest amount of my variables. How many a's are there? That's the smallest. A exponent 1 right there. How many b's can I take out? 2. Okay, it's my smallest amount there. So 2ab squared is my GCF. Okay, that needs to go on the outside of a bracket, and the inside is going to be the answer of when you divide them. So 2ab squared is outside, open a bracket. Now we're going to divide them. 10 divided by 2 is a 5. Subtract the exponents. So a3 subtract a1 is an a squared. b2 and b2 cancel. No b's left with that one. 8 dividing by 2 gives me a positive 4. a1 and a1 cancel. b3 subtract b2 gives me a b exponent 1. Do you have to show those hiding ones? No, but it's not wrong if you do. This would be my final answer. Okay? The only thing you could do next is look inside that bracket and see if the bracket breaks down. The bracket doesn't break down because I can't square root them and I can't take out another GCF. So it's done. Letter F is going to be done the same way. What digit will they all divide by? They will all divide by a 5. Okay? That's the coefficients you're looking at. That's what they divide by. If they were all negative, you would divide a negative out. Only one of them is negative, so we're just going to divide the positive one out. Now we look at the variables. Do they have an x and a y and a z in all 3? Yes. Then that means I can take an x, a y, and a z out. Now we look at how many come out. How many x's? What's the lowest amount of x's I have? I have a 1 right here, so x to the 1 can come out. What is my lowest amount of y's? 2. Okay, so a y2 comes out. What is my lowest amount of z's? 2. Good. So that's our GCF. And again, we're going to write it exactly the way we wrote that one, where the GCF is on the outside of brackets, and the answer to dividing it is on the inside. So 5x y squared z squared is on the outside. On the inside, we're going to get 25 divided by 5 gives us a 5. Subtract your exponents. Well, x1 and x1 are going to disappear. y2 and y2 disappear. Then I've got a z exponent 3 subtracting a z exponent 2 to give me a z exponent 1 left over. I look at the middle term. A negative 20 divided by a positive 5 is going to give me a negative 4. And now I look at my x's. x2 subtracting x1 gives me an x1 left over. y4 subtracting y2 gives me a y2 left over. And I have no z's left over, they're going to cancel. Now I take a look at my very last term. We have to move these guys over, I'm running out of room. Nope, not like that. Okay, so last step now, we're going to take 30 and divide by 5 and get a positive 6. The x4 subtracting x1 gives us an x cubed left over. y2 and y2 disappear. And z5 subtracting z squared gives us a z exponent 3. That is our final answer. You cannot go any further. Check your work. Okay, yo, Miss Tuck signing out. This is part 1 of lesson 2A.